Students, this is the help video for the Unit 2 study guide written questions A, B, C, D, E, and F. We're not going to do all of the problems. Just give you a little shove in the right direction. It's your job to finish the problem appropriately. So you always start by reading aloud with your finger on the paper. So follow along and read aloud with me, finger on the paper. Segment AB has a midpoint of R. Point D is a midpoint of RB. Point E is a midpoint of DR. Point B is at the coordinate 42 on the number line. And the distance from E to A is 40. Draw and label the diagram. Draw or insert bunny hops or brackets to represent midpoint and relative distances. Finger pinch these bunny hops. Then find all possible segment lengths and coordinate positions of each point. So you want to draw this to scale, and we're going to take it one piece at a time. And I recommend you color code. So we're just going to do that. Segment AB has a midpoint of R. So here's AB, midpoint of R. So R is a midpoint of AB, which means, again, it said use bunny hops or brackets, that this distance, A to R, and R to B, has to be equal because of that midpoint. Next, D is a midpoint of RB. So here's RB. D is our second midpoint. Okay, that implies that from, I'm going to overlap but color code, from R to D and D to B must also be exactly the same. Double hatch, because it's your second midpoint. E is the midpoint of DR. So here's DR. E is the midpoint here. It's our third midpoint, which implies, I'm going to bunny hump this one, that R to E and E to D are also equal. Triple hatch. Point B is at coordinate 42. 42 is a position, not a distance. So 42 is a position, not a distance. But we are given a distance from E to A, and I know it's a distance because I use the term 40 units. So from A to E, I have 40 units. Find everything you can. The trick to this is using your fingers to finger pinch stuff and ask yourself what is equal to what. So do you see? Let's start with the small stuff. RE is equal to ED. Go like this. RD is equal to RB, which means these two yellows are equal, which means I can carry over these pink bunny hops. Because the yellow is two pinks, I can carry it over. Always do what you can do. Even if it doesn't help you, you're like, well, what can I do? Let's see what else is going on. This blue is equal to this blue. This blue has 1, 2, 3, 4 of those original bunny hops, and all of them are equal because of that midpoint. Because this was equal to that, carries over. This is equal to that. So I can bring 4 bunny hops over here. 1, 2, 3, 4. And they're all equal. 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. So let's look at what you have here. The entire length consists of 8 bunny hops. The only distance we're actually given is this 40. So bring it up. Do you see that 40? That 40 has 1, 2, 3, 4, 5 equal slices, 5 equal pieces. So now you could easily find the measure of one of those bunny hops and then find the length of all possible segments. Once you have the lengths, you can just backtrack 42, and then you figure out what that distance is with the 2 bunny hops, and then where would D be? That would be a coordinate position. And then one more bunny hop this way, where would the position of E be, and etc. We started this one mostly in class, but I'm going to go over it with you. The 2 things you are given is you are given an angle 107. I'm just going to sweep it right there. Everything, all these other numbers are just numbered angles. And you are given 122 over here. It says, lay your stir stick down on the dotted line and find all possible angles. Well, first thing you want to do is see the parallel. Just trace parallel lines with your fingers. Just trace them. Trace. So you got parallel there because of the arrow feathers. And you have parallel going this way. So because you have parallel, we're going to work this one stir stick, and we know this is 107. This is 107 because of corresponding angles. Alternate exterior, that makes this 107. And vertical here or corresponding to here, that makes this 107. So all of those pinks are 107 degrees. What else do you need to look for? Let's sweep. We got a linear pair there. It's 180. So I'm going to go 180 minus 107. And I get 73. So that means this is 73. Alternate exterior. This is 73. Vertical angles here. This is 73. Armpits of the Z. This is 73 degrees. Now it says move the stir stick to the dash line. So I'm going to go this way. And I have parallel lines here. So that carries over the 107 to here, corresponding here, alternate X. Because we're parallel over here, that's 107. This whole thing is 107 as well. All the pinks are 107, which means I'm going to squiggle it. 73, of course, 73, and you can work it from there. Now, one thing you want to watch out for is this 122 is a different stir stick. Notice it is not parallel to this line. So you cannot carry over that 107 over here. Instead, it's its own stir stick, and you are going to work this armpits of the Z, and then we have 122 over here, and go ahead and find every possible angle. The only thing I want you to be careful of, watch out for these couple things. This and this hatch mark mean those are equal. Also remember that triangles, which we have one right here, always add up to 180. Find all the angles and then be prepared to explain on the right-hand side. C, it says, sweep and mark the given angles and note the given relationship. Then determine which lines must be parallel and why. When referring to lines, use the following: line HC, line EG, line AE, or line BF. Use the diagram to the right. We're only going to do the one here. So it says sweep angles 1 and 2. So I come over here and I'm going to sweep angle 1 and angle 2. I'm going to lay down my stir stick. The stir stick must touch both angles, and then the lines that are going to be parallel cut across the stir stick, but touch both angles. So if we're working with these angles, these are the lines that are going to be forced to be parallel. I'm going to trace them. So it says right here that they are congruent. Angles 1 and 2, even if they don't look congruent. Angles 1 is congruent to angle 2. Lay down our stir stick. Now, which lines are parallel because of that? And that's going to be line HC and line EG. Notice I'm using the uppercase points. I didn't give you lowercase names to the line, like naming the whole line, line M or line N. So I'm forcing you to use the points. So HC the line and EG the line. Now, your explanation must consist of 3 things: the name of the angles, the type, relationship, and the punchline. This would be an example here. Angles 1 and 2 are alternate interior angles. So why is this? Why were those parallel? Because if alternate interior angles are congruent, if alternate interior angles are congruent, comma, then you have parallel lines. Name and type, alternate interior, relationship, congruent, then the lines are parallel. So that is an example of one of the 4. Taking a look here. Line P is perpendicular to line D, perpendicular. That's the symbol for perpendicular. Perpendicular. That means these lines must cross at right angles. So line M and line P are perpendicular. The equation for line M is 3x minus 2y equals 8. Line P is perpendicular to line M and goes through this point, -6, -4. So I'm going to just plot that right off the bat. -6, -4. So our line P has to go through this point. Write the slope-intercept form, which is y equals mx plus b form of the equation of line P, and graph both line M and line P. So step 1, it says change line M which is 3x minus 2y equals 8 to y equals mx plus b. So we need to get y by itself. So minus 3x minus 3x. Come over here, I have negative 2y equals negative 3x plus 8. When that's opposite of timesing is dividing, negative 2, 2, negative 2. My final equation is therefore y equals, double negative makes a positive, 3 over 2 x minus 4. That is my line M. Let's graph that. So negative 1, 2, 3, 4. And our slope is positive, goes up from left to right. So up 3 over 2, down 3 over 2 this way would also work. And all right. Our slope of line M is 3 over 2. We're asked, what is the perpendicular slope? Remember, they have to multiply to negative 1, so it's the flip and the switch. So we're going to go negative 2 over 3. That's going to be the perpendicular slope. So this is going to be our line M. So for P, we want it to have this slope and go through this point. So we're going to plug it into y equals mx plus b. Ready? Your y is going to be 4. See? Your x is negative 6. Your y is 4. Your slope is negative 2/3. You're going to solve from here. Technically, remember that's negative 6 over 1. You're going to solve for b, and then you're going to write the equation for line P, which will be y equals something x plus or minus something. Once you get that, you want to graph it. And that second line should be at right angle to the first and go through this point. That's D. E. We're going to read the whole thing. Segment EF intersects segment GH at point Q. Segment GQF is 2 times the measure of EQG. Angle EQG and GQF form a linear pair. Ray QI bisects FQH. QJ bisects IQH. Ray QK is interior to EQH, and JQH and HQK are complementary. Find anything and everything you can find, draw a diagram, show all your algebra. Super important you draw stuff to scale here. What scale means is when it says bisect, that means these two angles should look equal. When one angle is bigger than the other, it should look like that. So we have two segments intersecting, but it's very important you do not draw the segments equally, like this, equal. Because it says clearly that one angle is twice the size of the other. So automatically, you know, instead of your lines being equalish on both sides, it's going to be tilted with one angle obviously bigger than the other. So that's your cue to starting this correctly, is that one angle. We're going to have two segments, and one angle is bigger than the other. So you look very carefully, they intersect at Q. So I know this is Q. And it says GQF is 2 times as big as EQG. GQF is the bigger angle. GQF. So our GQF, it could be one of these two angles. It really doesn't matter. I'm going to work down here. So GQF is twice as big as EQG. That means E must be this way and H must be over here. So let's just double check, make sure that's drawn accurately. GQF is twice as big as EQG. That looks about right. So we know that this, we don't know this, we're going to call this X, this 2X. So I'm just going to sweep this here, and you should see immediately how you're going to solve for X, but I'm not going to do that for you. Okay. They are, however, a linear pair. Share a spine, make a line. It says that QI bisects FQH. So here's F, QH. QI is going to cut that in half. So we want to draw it to scale. So QI, which means these are equal. And QJ bisects IQH. So where's IQH? IQH is right here. Sweep, that means QJ cuts this in half. So QJ. So that's our second bisector. So that's double hatch mark, double hatch mark. So this is a bisector, that's a bisector. Last one, ray QK is interior to EQH. So interior, here's EQH. So QK is somewhere in here. So that JQH and HQK are complementary. Complementary means angle plus angle equals 90. So here's one angle. And we want to create another angle so that it creates 90 degrees. So you kind of eyeball it. Look here. That's going to be our K. And I'm just going to darken it so you can see it. You want to make it kind of drawn to scale. So that should look 90 degree-ish. All right. They are complementary. So complementary means that this adds up to 90 degrees. Knowing all this, find all possible angles. And last problem, it's a proof. And we're going to follow given, implied, freebies, talk it through. And after talking, you must write, okay, a summary. And you have to have 3+ sentences. It says, given, the measure angle 1 is 100 degrees. And measure angle 3 is 80. Explain how you know line N and line M must therefore be parallel. Okay, I'm going to put a little arrow feathers, but I'm putting a question mark because you aren't told the lines are parallel. That's not part of your given. You're only given these angle measures, and you have to prove or explain why the lines are parallel. So this, you can solve this a couple different ways. One of the most important ways is to ask, okay, so that's done with given, implied, and freebies. Ask yourself, well, what else is true in this diagram? Well, what else is true is 1 and 2 are a linear pair. Means they add up to 180, which forces angle 2, of course, to be 80. You aren't given that angle 2 is 80. You have to explain why it's 80 because of a linear pair. Or you can do this, going this way. This is also a linear pair, which means angle 4 must therefore be 100. So there's a couple attacks you could use to prove these lines are parallel. Working the linear pairs, one of the methods you can say, now knowing if angle 2 is congruent to angle 3, then corresponding angles are congruent, punchline, therefore the lines are parallel. That would be angle 2 and 3. You're going to connect the fact that they're corresponding, they are congruent, therefore the lines are parallel. Or another attack you could go is you could highlight, because of the linear pairs, that angle 1 and 4 are congruent now. Those are alternate exterior angles, and you could write a sentence like, the measure angle 1 is 100, the measure of angle 4 is 100. And since they are alternate exterior angles and they are congruent, therefore the lines are parallel. Name, relationship, punchline.